Alright guys, welcome back. Today we are talking about percent markups and discounts. We're going to be using the same types of things we used yesterday with percent change to do these today, so it should be pretty easy for us. So first of all, do our vocabulary. markup, the increase in price from wholesale to retail. Wholesale is what like the big stores would buy it for from the actual company, the manufacturer. They buy it for a cheap price, and then they mark that price up to sell it to the consumers, and we would be the consumers. We buy things at retail price. So in order for the store to make money, they have to increase their price, sell it for a different rate, and sell it for more than what they bought it for. And that's what the whole process of markup and discounts is going to be about. So the markup is the amount of the price increase from the buying price to the selling price. A little bit of a thing here. Retail is the wholesale plus markup. So the company buys it for wholesale, they mark it up, and then they sell it for retail. So that add up. Markup, your change is your retail minus the wholesale. How much did they change? You can subtract what they're selling it for and subtract, how much they paid for it. Discount, same kind of thing. That's like our sales. When things go on sale, that's a discount, a decrease in the retail price of an item. So sale price equals retail minus the discount. And you can pause this if you need to have more time to write these notes down. Moving on to our first example here. You guys do not have this on your notes, but I'm going to do one for you just so you can kind of see what it looks like, so you don't need to worry about writing anything down. And then we'll do some together, and then I'll give you guys some time to work on your own. So here, this one says, a jacket has a wholesale price of $64. So that means the company originally bought it for $64 from the manufacturer and was sold at a retail store for $120. What is the percent markup? Well, we can look just right away. We can look and see, well, 120 is about double 64. So when we get our answer, it should be almost 100% markup. If we're not quite 100%, then maybe we did something wrong. So we'll kind of see what happens here when we do our work. So find the amount of markup. What was the change? How much did it change? So to do that, I do subtraction. 120 minus 64. I always take the bigger number, subtract the smaller number to find my change. And my 120 subtracting 4, I end up with 56. So 56 is on top. My original, which was 64, goes on bottom, equals my percent change over 100. And I do this math, 56 times 100 divided by 64. I end up with an 87.5% markup. All right, so I'm finding the amount of change. So it's an 87.5% markup. And that kind of makes sense, because if it was 100%, it would have been 128. Because if you would have doubled it, it would have been 128. And we didn't have quite 128, we only had 120, so that makes sense. That's a reasonable answer. So we move on now. We'll do one together as a group. So it says you are shopping for a bicycle and find one with an original price of $240. And you have this example in your notes. The store is offering a 35% discount on all bikes. What is the sale price for the bicycle? So the first thing we have to do is figure out, well, what is the discount? How much am I going to save? What's my money going to be that I'm saving? Well, I don't know that. So that's the part that I'm trying to find. So I'm trying to find that change. So X over the original price is 240, equals, what is my percentage that they're giving discount? 35% over 100. Okay, so I'm trying to find out how much of a discount I'm going to get. So I take 240 times 35 divided by 100, and my discount then is $84. So I'm going to save $84. Is that my final answer? No, because it's asking me, what is the sale price? How much am I going to pay total? Well, I have to take the sale price. To find that, I take the original and I subtract the discount. So I take 240, subtract 84, and my new answer then becomes $156 is what I save, is what I pay for the bicycle. Okay, moving on to the next example. These are very simple ones. The original price is 56, and our percent discount is 15% off. So I'm going to set that up. My original always goes on the bottom. I'm trying to find how much did it change, and I know my percent off is 15%. So So I find 15% of 56. And this example, if I do the math, it becomes $8 or $8.40. So that is my discount, but I want to figure out what is the sale price. So I have to take the original 56 and subtract the sale price, $8.40. And if I do that, I end up with $47.60. Oh, my marker's kind of messing around here. $47.60 is my sale price. That's how much I would pay for whatever object I was buying. Next one, exact same thing. I'm trying to find my discount. So X over the original, $70.90, equals 40% over 100. Do the math here. X equals 28.36. Then I subtract from the original. So I take $70.90 and I subtract $28.36, and my new sale price is $42.54. All right, remember, don't forget, if you want to check these out, work them out with the calculator, you can pause the video and double check your work to make sure that you can find these answers. Okay, moving on to the back of our notes. Word problem. The pair of sneakers has a wholesale price of $28, so that's what the company buys it for. The percent markup is 135%. We're going to figure out how much is the store going to sell those sneakers for. So we set up our equation. We have to find that change. How much are they going to, add to the price? So that's going to be my change. Over the original is 28. We know the percent always goes over here. It's 135 over 100. Do the math here. 28 times 135 divided by 2 or 100. And I get $37.80. That is how much they are going to mark it up. And that number is bigger. It's 135% of 28. So we are expecting it to be bigger than 28, and that is, so that's a good thing. And now we take that and we add the markup to the wholesale. So we add that $37.80 to the original price, which was $28, and we end up with a grand total of $65.80. And that is how much they would sell that for in the store. So they're going to be making some profit then. All right, and we could calculate how much profit by subtracting. But really what they wanted to know was what is the retail price, and that would be our answer right there. Okay, a little bit more. These things are the exact same types of problems that we just did with the tennis shoes or the sneakers. The wholesale price is $64. That is our original. We're trying to find out how much they're going to increase it, and the markup is 90%. 90% is almost 100, so it should be pretty close to 64 when we get done. And we know 100 goes here. Solve our proportion. X equals $57.60. And that's pretty close to 64 because we knew it was going to be close. So now I take that and I add it on to find the retail price. So I have to add my original 64 plus my markup, which was $57.60, and my grand total comes out to be $121. I'm sorry about my marker not working right, and 60 cents. It's sticking for some reason today. $121.60. That's sticking again. Oh well, we'll get over it. Number 2 over here, same exact format. I'm trying to find the change. So X over my original, which was 29, equals my percent. Well, this is frustrating. 105 over 100. Okay, do the math here. X ends up equaling, I'm going to pause the video for a second. All right, sorry about that. We're going to try it one more time now that I've gotten a new pen, see if this works any better. If not, we're just going to have to deal with it. So my original is 29. I'm trying to find the change. My percent markup is 105 over 100. I multiply and do all the work, and I get X to be $30.45. So I take that original price, or that new markup, and I add that to my wholesale price to find the retail. So 30.45 plus 29 equals $59.45. And that is my retail price. circle this one down here. I think it was 121.60. Okay, moving on to the next problem. A snowboard costs $116 before tax. The sales tax is 6.5%. What is the total cost? Sales tax is an additional charge that they add on to the price of the object that you're buying. So I need to find out how much would that percent be of my original cost. So my original cost is 116. I'm trying to find out what would that 6.5% be. So I do the math here. Do the tax. X is going to equal $7.54. And now it says add the sales tax to the original price. So my original was 116 plus my $7.54 ends up giving me $123. And 54 cents. I was making sure that I was doing the math correctly. $123.54. Moving on to the next one. Same exact types of problems here. We have a price, they give us a tax, we have to find out what the actual price that we pay. So I'm trying to find what percent of 33, or 7% of 33, and my X in this example equals $2.31. Add that to the original, $35.21 is my answer. 31 cents, sorry, 31 cents. Okay, over here, same exact format. I would set up X over my original equals 5.5 over 100. Find X and then add it to the original, and my final answer becomes $110.73. I just went through, I just did the answer on that one so I don't run out of time. I only have about 3 minutes left, and I wanted to do at least one more example of the next type of problem. This one here says you order pizza to be delivered. The bill is $16. You give the delivery person a 15% tip. The sales tax is 5%. What is the total cost of the pizza? So in this example, what we're going to do is we're going to find the tip first. So we need to find out how much the tip would be. So X over the original, 16, equals, we said 15% tip over 100. So X is going to equal $2.40. Then we're going to find